So welcome everybody to this latest video on 162 Maths, and in this video we'll be doing a GCSE revision video on the equations of a straight line. Now I know we will go through some past exam questions. I'll also show you what it is you need to revise and the key formulas you need to do. Now a copy of the question sheet is available for you to download and have an attempt at before watching through this video once you've understood the topic and to test your prior knowledge, and then you can continue watching this video as we go through the answers. Now before we get started working through some exam questions, let's just quickly go over the key formula and notes on the equation of a straight line. Now here, when we look at the equation of a straight line, there are two main formulas that are more commonly used in GCSE level and also creeping into additional maths, further maths and A-level maths. And they are y equals mx plus c, where m is the gradient and y is the intercept. Now, when you are using this equation to either read information from it, it is really important that you do make y the subject. So here you always need to make sure that y is the subject. Now, in some cases that may not be always the case, and we'll show you this when we look through some common past exam questions. But again, if you want to know what the gradient is and the y-intercept from an equation, you have to make sure you've got y equals. Now, when you are actually working out the equation of a straight line, one alternative sort of formula for you to use, or equation for you to use, is this one here, which is y minus y1 equals mx minus x1. Now this is basically an expansion of y equals mx plus c, but here you don't need to find the y-intercept. Here all you need is the gradient of between 2 points that lie on the line, and also one of the coordinates that lie on the line, and this is usually given to you either in worded problems or contextual problems or in graphical questions. So in graphical questions, a lot of students tend to opt for y equals mx plus c because it's easy for you to work out the gradient, which is always going to be the same regardless of which equation you use, but the y-intercept is the clincher because it's easier to spot what that number is going to be. However, if you have not got a graph and you've got a coordinate, then one thing you may want to do is opt for this formula here, because it's all it case of doing is just substituting the values into this particular formula and then simplifying it if you need to. Now, when working out the gradient between 2 points, again, if you are not given a graph and when you are given two coordinates, there are two alternative methods you can use. But ultimately, to work out the gradient between two coordinates, we use this formula. Now, this formula is basically generally what you may have done already in terms of being taught how to work out the gradient. It's basically the difference in y over the difference in x. So again, looking at this, the difference in y in coordinate form is going to be y2 take away y1, and the difference in x is going to be x2 minus x1. Now, if you're thinking about where I'm getting these coordinates from, basically, typically you'll be given two coordinates. So if I just make up some numbers here, let's go for -5, then this value here would be my x1, this would be my y1 because I've used this as my first coordinate, and this would be my x2, and this would be my y2. And then all it's a case of doing is substituting those values into this formula to, done that one wrong, apologies. That one should be there, and this one should be here, and that one is there. Now again, where a lot of students tend to go wrong is they get this order of the formula mixed up, because you think, oh, x, y coordinates, they think the difference in x goes at the top and the difference of y goes in the bottom, and that is obviously incorrect. So really make sure that you are substituting the correct lines of working out into that formula. Another thing you may get asked is to work out the intercepts. Now again, if you're given a graph, it's going to be relatively easy. It's just a case of just looking at the graph and seeing where it crosses the x-axis and where it crosses the y-axis. But again, if you're not given a graph and you're yet asked to find these things, then all you need to do to find the y-intercept is basically substitute x equals 0 into the equation and then solve it for y. Alternately, if you want to find the x-intercepts, all you need to do is make y equal to 0, substitute that into the equation, and then solve it for x. Now, with a straight line graph, you're always only going to get one answer for either of those. Another key thing with regards to related to gradients is parallel lines. Now, parallel lines have the same gradient, so always make sure that you're aware of that. Now, perpendicular lines, now this one does probably go into more higher, but basically the key property of perpendicular lines is that they are the negative reciprocal of each other. And what we're talking about here is that the gradients are the negative reciprocal. In fact, let me just edit that, because it should say the gradients are negative reciprocals. And let me just get rid of this word there. And so again there. Now, in terms of if you ever get asked to prove that two lines are perpendicular, or it represents a right angle triangle, then one proof that you might want to say is this, that if they are perpendicular or produce a right angle, then the gradient of BC and AC should equal -1. Now again, that's a very A-level-esque proof, but if you're doing high GCSE, you may want to start using that now. Commonly for many GCSE students, they tend to say that if they are perpendicular, then it's either going to be the gradient of AB is going to be -1 over the gradient of BC, or the gradient of BC is going to equal -1 over the gradient of AB. And again, if this makes absolutely no sense to you at all, do not worry. There'll be some questions that test this knowledge, in which we'll be recalling this proof in due course. The last thing to move on to is gradient from a graph. Now here, again, what you want to do is note that two coordinates are on the line. So if we, let's say, wanted to work out the gradient of this, now what you want to do is you would need to pick two nice coordinates. Don't go for some random coordinates where it's really difficult to read. They're halfway in between boxes. Just try and pick two nice coordinates. And again, when you're looking at the coordinates, always think about the scale that's being used. So for example here, if this measurement here was -5, and let's say this is 8, it's completely off scale. Let's say this is 20 and this is -8. Then this coordinate here is going to be -5, -8, and this coordinate here is going to be 8, 20. Now from this, what you then want to do is you then want to turn that into a right angle triangle. And from that, what you then want to do, and again, that really should go through the line, and we'll just make that a little bit better. I feel as if this is going to get rid of the line. Oh, not quite. And so if I just make that there, and draw a line like so. So looking at this, the difference between the y-axis from -8 to 20 is going to be 28. So let me just write that here, is 28. And the difference in the x values is going to be 8 minus 5, which is going to be 13. And don't need to worry about the negatives in this case. So let me just write 13. So once I've worked out the height and the base of that triangle, I then use this formula here to work out what the gradient is. So it's going to be the height, so m, or the gradient, is going to equal 28 over 13. Can I simplify that? No. So I'm just going to leave it as that there. Now, the next thing for you to bear in mind is just make sure that you're aware of the correct sign of your gradient, because if you are using this method and you're working out the base and the height of the triangle, you might ignore the direction of the line and also therefore get the gradient wrong. So if your line is going up, then that equals a positive gradient. And if your line is going down, then that means it's going to be a negative gradient. So once you've used this method, just make sure that you're either deciding whether it's a plus or a minus depending on the direction of the line. Now, just a little reminder that if you're wanting to have an attempt at the following questions that we're about to go through, taken from past papers, then all you need to do is just simply click on the link in the description, download the paper, have an attempt at the questions, and then come back to watch this video so we can go through the answers. Alternatively, what you can do is you can pause the video as I'm reading out the question, have an attempt at it, and then unpause so we can see if it's correct. So let's get started on these questions then. So looking at question 1, it says that line M has the equation of 3x plus 2y equals 7, and the question is asking us to circle the gradient of line M. Now, as I've mentioned, to work out the gradient of a line taken from its equation, you need to make sure that you've got y the subject. So what I need to do is I need to rearrange this. So I've got 2y equals 7 minus 3x, and then I've got to divide by 2, so I get 7 over 2 minus 3 over 2x. Now the gradient is the coefficient of x, or in other words the number in front of x including the sign. So here the answer is going to be minus 3 over 2. It then says for question B, it says that line M has the equation of y equals 5 minus 3/4 x. Circle the gradient of the line that is perpendicular to the line N. So here what we've got is the gradient of this line is minus 3 over 4. So then the gradient of the perpendicular line is going to be the negative reciprocal of this. So it's going to be minus 1 over minus 3 over 4. Now here, two minuses make a plus. And when I do working out the reciprocal of a fraction, all I've got to do is flip the fraction. So it becomes positive 4 over 3, which is my third option. Looking at question 2, it says that line A has the equation of y equals 4x minus 1. Line B is perpendicular to the line A and passes through the point 85. Work out the coordinates of the point where line B intersects the x-axis. So again, in this question's worth 4 marks, so quite a lot of marks here. Now the first thing I need to do is basically find the line B. So let me just write down what I'm doing here. So find the equation of line B. Now to do that, I need to know the gradient and I need to know the y-intercept or a coordinate. Now here I know a coordinate, so this is going to be my x1, y1, and using this information that I know it's perpendicular to line A, let's work out the gradient. So here m is going to be, and it's going to be the negative reciprocal of line A, so it's going to be minus 1 over 4. So then using, this is my m, this is my x1, and this as my x2, I'm going to find the equation of line B. So line B is going to be y minus 5 equals minus a quarter x minus 8. Then from this, what I then want to do is expand the bracket. So I've got y minus 5 equals minus a quarter x plus, and then a quarter times 8. Well, if I do it, change that 8 to a fraction. 8 times 1 is 8, 4 times 1 is 4, so 8 divided by 4 is 2. And then from this, I can then take the 5 over, so it gives me minus a quarter x plus 7. So that there is the equation of line B. Now the question doesn't ask for that equation, it says to work out the coordinate of where line B intersects the x-axis. So here it intercepts the x-axis when y equals 0. So if I substitute y equals 0 into this, then what I get is 0 equals minus a quarter x plus 7. So then minus 7 equals minus a quarter x. Now another way of writing this is to write it like this. So I've got minus x over 4. I take the 4 over, so that becomes minus 28 equals minus x. So x equals positive 28. So the coordinate where it crosses the x-axis is going to be at 28, 0. Moving on to question 3, it says that point P is at the point 2, 14, point Q is at the point 6, 8, and point R is at the point 2, 5. Use the gradients to show that the angle PQR is not right angle. So for here, with these types of proof questions, what you want to show is if not right angle, then the gradient of PQ times the gradient of QR is not going to equal minus 1. So what I'm going to do is I'm going to work out each of these individual gradients. So here the gradient of PQ is going to be equal to, now looking at this, so if I use P as my y2, x2, so that's going to be 14 and 2. Q is going to be 8 and 6. And you just want to make sure that you are using those coordinates in the right order. And again, so the formula I'm using is m equals y2 minus y1 over x2 minus x1. Now, it doesn't really matter what order you pick as your x2 and which one, sorry, your second coordinate, which one you pick as your first coordinate. As long as that's one coordinate and that is another, you should be fine, obviously in the reverse order. So looking at this, that's going to be 6 over minus 4. And if I simplify that, that's going to be minus 3 over 2. I then work out the gradient of QR. So looking at this, I'm going to use 8 and 6, 5 and 2, and I take them away. So 8 take away 5 is 3, 6 take away 2 is 4, so that becomes 3/4. So as minus 3 over 2 multiplied by 3 over 4 is not equal to minus 1. PQR is not, oh, don't know why I went a bit crazy with the crossing of the T there, is not a right angle. So moving on to question 4, it says that ABC is a straight line. A is the point 0,8 and B is the point 40. C is the midpoint of AB and the line DCE is perpendicular to the line ACB. And the question is asking us to work out the line of DCE and it's worth 5 marks. So a big mark question here. So looking at this, let's have a look at the key facts. So C is the midpoint. So in order to work out the equation of this blue line, I need to know the gradient of that line and I need to know a point. Now the point I know is going to be C, and I also know that the gradient is perpendicular to the line AB. So if I first of all work out the gradient of AB, so again looking at the coordinates, this coordinate here is going to be 0, 8 and this coordinate B is going to be 4, 0. So substituting those numbers in, I get 8, 0 minus and it's going to be 0, 4, which equals 8 over minus 4, which equals minus 2. Then if I then work out the point of C, so C, which is the midpoint of AB, now I can use a formula which is A1 plus A2 over 2 and then Y1 plus Y2 over 2 gives me my midpoint. But what I'm going to do is I'm going to be a little bit smart about this one. So here C is in between 0 and 8, which is 4, and the x ordinate is going to be between 0 and 4, which is 2. So C is going to have the coordinate of 2, 4. So then using this information, what I'm then going to do is I can then work out what the equation of the line D or ED is going to be. So from this, what I can then do is going to be y minus, well, let's first of all work out the gradient. So here the gradient of EDE is going to be, or CDE I should say, is going to be minus 1 over minus 2, which is positive 1/2. So then from this, using this as my m value, and this coordinate, which I've just completely obliterated, so let me try that again. There we go. So then from this, what we've got is m equals positive 1/2. We've got the coordinate of 2, 4. I use y minus 4 equals 1/2 x minus 2. Then expand the brackets, so it becomes 1/2 x, and that becomes minus 1. And then y equals 1/2 x plus 3. And there is my final answer, which looks correct because, again, this value should be between 0 and 4. And as you can see, it is. And I've got my positive gradient going upwards as well. Now, moving on to question 5, it says that a law firm A uses the graph to work out charges. And question A is asking us to work out the equation of the line in terms of C and T. So from this, what we try and do is work out the gradient, the equation of a line from its graph. Now, again, this is going to be quite awkward for you to go for, but what we want to try and do is we want to try and pick two nice coordinates. So this coordinate here is 0, 50. And we then need to pick another coordinate, which I'm going to go for this one here. And that coordinate is 120 and 210. So from this, what I can then do is if I turn that into a right angle triangle, I then work out the difference in the y ordinate, so the difference between 210 and 50, and that's going to be 160. And then the difference between the y ordinates, the x ordinates, which is 120. So here, the m value is going to be 160 over 120. And if I simplify that, just assume that this is going to be on a non-calculator. So we've got 8 over 3. And then that then becomes, it's going to be 4 over 3. Now I've got 8 from divided by 2. So that's going to be 4 over 3. Then once we've got this, I can then pick a coordinate. So I'm going to go for this one here. So the equation is going to be C for the charge equals 4 over 3t plus the y-intercept, which is 50. So it's going to be plus 50. Now again, alternately, I could have just done c equals minus and then a coordinate, which is the y-ordinate, which is 50, equals 4 over 3t minus 0, in which I'd get the same equation. So that there is my equation there. Moving on to B, it says law firm B uses the table to work out the charges, and it says draw the graph on the same grid to represent law firm B's charge. So a time that's between 0 and 60 is going to be a fixed charge of 120. So if I go back to the graph, now what I'm going to do here is, now typically you wouldn't do this as an exam, is to get rid of all your working out, but I'm just going to do that just to show what these are. So here, from 0 to 60, it's a flat charge of 120 pounds. So that's going to be a straight line up to 60. Then it says that from 2 hours, from after 60, it's using the equation of 2t. So again, from this, at 60, it's going to be 120. And then if I pick another value, so let's go for 210, if I times that by 2, that's going to be 420. So if I find 420 going up this line, and I make it out to be about there. And again, yours are going to be a lot accurate because I'm reading this off from a graph from the screen. And so let me just make sure and try and get this as accurate as possible. But basically your answer should look like a horizontal line followed by a diagonal line. And what I then need to do is just drag this a little bit further up to the edge of the graph. So it should look something like that. Then for part C, it says how much cheaper is law firm A to law firm B for 3 hours. So looking at law firm A, that a 3-hour job, which is 180 minutes, is looking at to be, and so if I mark up where 180 is, I'm looking at that point there, which I make out to be 290. So law firm A is 290. Now then for law firm B, all I need to do then is use this formula, which is going to be 2 times 180, which is 360. So then what's the difference? Well, it's going to be 360 minus 290, which is £70. For question 6, it says the equations of 5 straight lines are given below. The line of y equals 3x minus 1 is parallel to 2 of the lines. Circle the equations of these 2 lines. So if it's parallel, basically it's going to have a gradient of 2. So looking at this, a gradient of 3 rather. Where am I getting 2 from? Gradient of 3. So I'm looking at positive 3 as well. So here I'm looking for y equals, and the 2 equations I've got gradient of positive 3 are going to be these 2 lines here. Moving on to question 7, it says that lines y equals x minus 1 and x equals 2 are shown on the grid, and it says draw a reflection of the line y equals x minus 1 in the line x equals 2. So from this, I've just got to reflect it from this mirror line here, and if I plot those points like so, and then all I then need to do is with a ruler is join those points up. Now you don't need to mark all the points, just a few, enough for you to join those points, and I would say that's pretty accurate as I can get on the computer. It then says work out the equation of the reflection line. Now for this you can obviously use the graph to work it out, but I'm going to be using the equation to then work this out. So here we've got y equals x minus 1. Now the gradient of that line is 1, so therefore this purple line is going to have a gradient of the negative reciprocal of 1, which is minus 1. I then pick a coordinate that it passes through, which this coordinate here is 2, 1. So using that coordinate and this gradient, I'm going to go for y minus 1 equals minus 1 x minus 2. So y minus 1 equals minus x plus 2. So y equals minus x, and it's going to be plus 3. and there we go. Alternatively, what I could have done is, rather than using that, once I've got the gradient, I can see where it crosses the y-axis. So here m equals -1, c equals 3, so it's just going to be y equals -1 x plus 3, and again exactly the same answer. You may have found that a lot quicker. So moving on to question 8, it says the gradient of the line OR is 7, 4, PQ is perpendicular to OR and P is the point 14, 0. And the question is asking us to write the equation of the line PQ, giving our answer in the form of AX plus BY equals C, where A, B and C are integers. So let's first of all work out what the gradient of the line QP is going to be. So if it's perpendicular to this, the gradient of PQ is going to be the negative reciprocal of 7 over 4, which is -4 over 7. Then using the coordinate of P, which is 14, 10, so then we've got 14, 0. We're going to use y minus y1 equals mx minus x1. This is x1, that is y1, and this is my m. So from this we get y minus 0 equals -4 over 7 x minus 14. Then if I multiply everything by 7, so I'm going to multiply that by 7, that by 7, then what we end up with is we're going to end up with 7y equals -4. Then I've got x minus 14. And then expanding the bracket out, I get -4x, and that's going to be plus 56. So then getting the x and y's all onto one side, so let's just take the -4x over to the side, so I end up with 4x plus 7y equals 56, and there is my final answer. Moving on to question 9, it says OABC is a kite, and the question is asking us to work out the equation of AC. So again, to work out the equation of AC, I need to know the gradient of AC. So again, using the formula, so the difference in y is going to be 4, 0. And here I've got 0, 12. So then the gradient is going to be 4 over -12, which is -1 over 3. And then from this, I know the y-intercept is 4, so that equals m. C equals 4. So the gradient of the equation of the line is going to be -1 over 3x plus 4. Now moving on to question B, it says work out the coordinates of B, and it is worth 6 marks, so it's going to be quite a big question to work this out. So the first thing I need to do to work out B is to first of all work out the equation of OB. Now to do that, what I need to do is I notice that from the information that's given to me on the diagram that the line OB is perpendicular to CAC. So here then that the m is going to be -1 over the gradient of AC, which is -1/3, and minus becomes a positive, and I've then got +3 because we then become 3 over 1, which is just 3. Now the y-intercept is 4, so then C equals 4, so the equation of the equation OB is going to be y equals 3x. Now the next thing for me then to do is to work out the coordinate of where those two lines intersect, which I'm just going to call D, so the coordinate of D. Now to do this, what I need to do is I need to use simultaneous equations using those two lines. So y equals 3x and y equals -1/3x plus 4. Now because they're both equal to y, I'm going to use the substitution method to work out the coordinate of where those two lines intercept. So I get 3x equals -1/3x plus 4. Now if I take the 3 over and multiply everything by 3, I end up with 9x equals -x plus 12. And then from this, what I can then do is take the x over, so I end up with 10x equals 12, and so x equals 12 over 10, which is 6 over 5. Now once I've got that, if I just convert that into a decimal, that then becomes 1.2. So this coordinate here is 1.2, and so let's just write 1.2. And then the next thing for me then to do is to work out the y value. So here, so y, using y equals 3x, if I multiply that by 2, I get 3.6. So this coordinate here is 3.6. Now, as that is a kite, it basically means that this distance here is, if that's 1.2, that means that this distance here is going to be 1.2. So B is going to have a x ordinate of 2.4. And if this distance here is 3.6, then this distance here is also going to be 3.6, meaning that the ordinate is going to be 7.2. So the coordinate of B is going to be 2.4 and 7.2. And if you wanted to write that as a fraction, you can do, but ultimately it should be those two values. Moving on to question 10, it says circle the equation of the line parallel to y equals 5x plus 2. So we're looking for an equation with a gradient of 5, positive 5, and that is going to be our second option. For question 11, it says circle the equation of the line that is parallel to y equals a half x plus 3. So we're looking for m equals positive a half, which again is our third option. Don't know why I said again, but there you go. Moving on to question 12, it says here is the line L and the graph y equals x minus 1. The scales of the axes are not shown. Work out the equation of line L. So looking at this, if we look at this equation here, we can see that this crosses the y-axis. So this line, the y-intercept is going to be minus 1, which means that this is minus 1, which means every little box of 5 is going to equal 1. So that's going to be 1, 2, 3, 4, 5. Now we then need to find the x-intercept. So to find the x-intercept, what I've got to do is substitute y equals 0. So then 0 equals x minus 1, so x equals 1. So this point here is going to be, this point here is going to be 1. So then from there, that's going to be 2, and that's going to be 3. So every box of 5 going across on the y-x-axis is going to be 0.5. So from this, what I can then do is to work out what the gradient is going to be. So if I then work out the gradient of the line L, so if I use two nice points here, I've got one point here which is 0, 3, and I've got this point here which is 2, 0. So then drawing that triangle, I can see that the height of that triangle is going to be 3, and the base of that triangle is going to be 2. So looking at line L, M is going to be 3 over 2, and a coordinate that it passes through, I'm going to go for, well, it's going to be the y-axis is 3, so that means C equals 3. So then it's y equals 3 over 2x plus, and it's going to be 3. And there is my final equation for the line L. So moving on to question 13, it says minus 310 is a point on line L, 4, 0 and 610 are points on line M. L and M are parallel, and the question is asking us to work out the equation of line L, giving our answer as y equals mx plus c. So first of all, what we need to do is we need to work out the equation, the gradient of line M. So work out the gradient of M. So turning that into a triangle or using these two coordinates, again it's entirely up to you, but we should see that the height of that triangle is 10. The difference between the y-x ordinates is 2, so the gradient then is going to be 10 over 2, which is positive 5. So then the gradient of L is going to be 5 as well. So then picking a coordinate, which is minus 3, 10. Substituting that in, we get y minus 10 equals 5 minus, it's going to be x. X, and then it's going to be minus 3. So here we've got y minus 10 equals 5x plus 3. So y minus 10 equals 5x plus 15. So y equals 5x plus 25. And there is my final answer. Moving on to question 14, it says A is the point 2 minus 5, B is the point 4 minus 9, and it says show that the gradient of the straight line passing through those 2 points is minus 2. So here then the gradient of AB is going to be the two y-ordinates, so minus 9 and 4, and then minus, no, it's not, yep, that's going to be right, and then here I've got minus 5 and 2, and we take away those two, so here 2 minuses become a plus, and that's going to equal 2, so I've got minus 4 over 2, which is minus 2, which is exactly what they wanted me to show. So then substituting these two values into this formula, then what we get, well, just the x value, we get y equals minus 2 times 3 minus 301, take away 1, this then becomes minus 602, take away 1, which gives us an answer of, well, plus 601 minus 1, which is 601. These two values are the same, so the answer then is yes. Then moving on to question 15, it says a straight line has the gradient of 6 and passes through the point 319. Work out the equation of a line, give your answer in the form of y equals mx plus c. So here m equals 6 and x1 equals 3, y1 equals 19. So then using y minus y1 equals mx minus x1, we get y minus 19 equals 6x minus 3. Y minus 19 equals 6x minus 18. Take the 19 over, so we get y equals 6x plus 1.